Hi everyone, welcome to IoT Show Deep Dive. Today we are going to deep dive into indoor maps with Azure Maps. Super excited for all of you to join right now live. And so if you have any questions during this deep dive, feel free to ask and chat. That's where I'll be hanging out, answering your questions. And also, if you are tuning in when this deep dive is on demand, don't worry, you can still reach out to us after the event. I will give you some resources and some links on how to contact us and to ask more questions. All right, so what are deep dives? So deep dives are a way for us to actually showcase a technical walkthrough and how you can get started. So for Azure Maps, today we're going to focus on indoor maps. At Build, we actually made a huge announcement that we have now that Azure Maps Creator is now in preview. And so if you didn't see that announcement, we do have a video that you can review and watch if you want to learn more about what that announcement was. But high level, Azure Maps Creator is a great tool for developers where they can upload private map information such as indoor floor plans, spaces, physical assets into a customer-controlled, highly secure, and fully compliant geospatial storage system within Azure Maps. So we have Roberto here. Hi, Roberto. Super excited that you're here. Do you want to give a little information on what you do on the Azure Maps team?
Hi, Pamela. Yeah, sure. I'm Roberto. I'm a senior program manager for Azure Maps, and I focus on this new capability called Azure Maps Creator and the connection with IoT.
Well, thank you so much for joining us, Roberto. Roberto is going to be our main speaker for today. He's going to give us the ins and outs. So let's go ahead and jump into what we're actually going to be doing by showcasing what we're going to, the agenda slide. So for the agenda, we are going to go through the introduction of what is actually Azure Maps Creator. So what are the features you're going to see in that public preview and how to get started. And then we're going to actually deep dive into how to create an indoor map and the data sources you can use, and also some best practices. So if you watched that video on IoT Show on the introduction for Azure Maps or indoor maps for Azure Maps, keep in mind, like this deep dive, we're going to go even more into what are the best practices and go into how to get started. And then next, Roberto is going to go into indoor maps in action. So he's going to go through the SDK. He's going to go through the different services. And then at the end, we're going to deep dive into all of the resources to help you get started. All right, so how about we just hand it over to Roberto. Roberto, I'm just going to ask you some questions throughout the event, but I promise I won't throw crazy curveballs at you.
Please do. Yeah, thank you, Pamela. Azure Maps Creator is just been released in public preview, and is a set of capability within Azure Maps that allows you to securely create and host and deliver maps that you fully own for indoor floor plans. And those are serving functionality for the map data owners, as well as those developing applications with IoT, to deliver smart building solutions. And we basically offer three main functional elements within Creator. The mapping as a service, a set of features designed to help you onboard data into the system. And then the exploitation phase with map service, rendering, spatial query, and then of course, good SDKs for you as a developer to build an application with a nice visual and with a nice browser and mobile support. The experiences that we are targeting are kind of summarized here. Those are the main, most common one, and they range between all the scenarios related to creating and maintaining the life cycle of a data set. So the whole data management experience, as well as the exploitation. So you, for example, can imagine solutions that deliver occupant tools, like find the closest and free meeting rooms, find where the temperature is too high or where a fire extinguisher has to be inspected, as well as even more in-depth analytics that can be combined, for example, with the power of time series insights to deliver analytics on space and time. Finally, we also cover location analytics in terms of spatial calculations. For example, a common scenario is support of geofencing within indoor spaces or asset tracking to deliver either VIP experiences or simply make sure that the assets are within the designated area.
And Roberto, could you give a little bit more examples of different use cases? I think the first one that comes to mind is kind of smart office solutions, but could you give a little bit more of other types of use cases?
Absolutely, you're right. Here, it's a little bit alluding to smart office, but the API and the system data model is designed to allow you to incorporate and customize your understanding of the indoor space. So it can be applied to retail, for example, to understand customer experiences, customer journeys. It can be a factory. It can be any environment through which you want to create mapping and location analytics.
And I'm also curious on what type of data can be used to actually improve Azure Maps?
Absolutely. So as we are introducing this new set of experiences designed to help customer create their own maps. So this is not designed to help improve the Azure Maps content. It's actually designed to help onboard your own private content. You fully own the sharing policy that you're willing to apply, and it can cover from CAD drawings to GeoJSON and other formats that I will illustrate later.
Okay, perfect. Yeah, I think it would be great to see what are the different data formats you can use, because I know that's going to be a big question for folks.
Absolutely. I'm going to talk a little bit about the conceptual phases that we have during the map creation workflow. So with Creator, we are introducing a number of different new services from conversion, dataset, tileset, and feature state. Those are cloud service hosted in Azure Maps, and conversion is responsible for validating and controlling that the schema, the data imported, is actually valid and can be processed. Dataset is our copy of record through which you can keep maintaining the data over time, make sure it's always reflecting the state of play, and out of which you can then create optimized data products such as Tile Service and Feature State Service, which are for rendering the reference data as well as rendering properties that are delivered at runtime. And those are basically all new features that play an important role in the ingestion workflow. So the most common scenario is during construction or even remodel of a building, you typically receive as part of your deliverable a drawing package. And that includes CAD drawings, typically DWG file format. And those are the things that we can import, let you upload in Azure Maps, and then process, convert one building at a time, and then you can build into the dataset. And this is where that data gets indexed and made available for exploitation. Now, if you want to do rendering, as I mentioned, you create the tile sets, and if you want to do feature state, you can make use of feature state service. And why do we add those additional capabilities? I'll start from dataset. As you just mentioned, Pamela, not only CAD drawings are very common, there are also other formats widely used, such as GeoJSON. So we have additional capabilities through the service to import, for example, furniture, equipment, like desk, chairs, printer, any point of interest or area of interest that you may want to represent through the bulk import as well. And we also know how hard it is in geospatial mapping solution to integrate, blend together information that you have knowledge up front with knowledge that only is made available during runtime. For example, device data, device telemetry coming from IoT systems. And in this case, what we do through Tileset Service is to enable dynamic map rendering based on information about spaces and objects that come into play only at runtime. So that's a very powerful tool to deliver on map application, always the latest, always the greatest, and in alignment with all the latest observations that IoT can bring. So as you have created a data set or more, what we do through Creator is to enable a number of service experiences that are available through the SDK, but also through the service API directly. And we have added a few interfaces like the OGC Feature API interface, which is an Open Geospatial Consortium standard, which means highly interoperable with many other systems, but also made use of the existing service to expose this additional content. So you don't need to build a new skill set, for example, to create map visualization. You can use the SDK and the render API you are familiar with to actually deliver the same additional augmented experience. And you can combine this with all the API and services that Azure Maps provide, like weather, forecast, very frequently used in energy management solution, route, mobility, and so on.
Roberto, I'm curious because I'm looking at the two images. What happens if you have a building with multiple stories, different levels? How do you do that using the SDK?
We have developed an indoor module for the SDK, which is fully integrated within the SDK package. If you are willing to use it within the SDK, you can simply augment the experience. You see here our satellite imagery, which is already available in GA, combined with the power of indoor visualization. So those are actually delivered using the same SDK and skill set.
Okay, so you can have these buildings, they can have multiple stories, and then what if you want to create maps with multiple buildings?
It is important for us to make sure that if you are having applications in which it is useful for you to have indoor knowledge as well as outdoor knowledge, to make sure that you can georeference those buildings. So we provide georeferencing tools as well as the ability to add to the same map, the single map and single data set, multiple buildings. And this is unblocking and simplifying a variety of experiences like query. Where are the mid-sized meeting room? You can, with a single call, query across 100 buildings if that is your data set, if that is your scenario. And it's very flexible. You can go from one building with one floor to multiple georeferenced buildings that combine, that are exposed to the same interface.
Okay, great. That makes sense.
And to conclude, and then I would like to kind of switch to more live demos so you can learn a few elements and decision points where it is important to be aware of the options. This is the indoor module that we delivered. As you can see here, it allows you to reflect in the map multiple level of details. It has a floor picker, which allows user to switch between one floor and the other, and also has the ability to combine indoor and outdoor. So if you are, for example, willing to know how long it would take for a field operator to reach the building, you can first make use of the routing API and then combine with the knowledge you have about the indoor.
And I'm excited for you to do that technical walkthrough and show folks how to get started. Also, something that I think would be really valuable for folks to see is how can you check that the data is correct? So if you're onboarding all of these indoor floor plans from different formats, what would you recommend as best practices to see if this data is correct and upload it correctly?
Very good question. So we, as part of the conversion service, we also defined a schema, which helped us share knowledge about the expectations and the opportunities to adhere with that specification. In addition, which helps our customer to onboard at scale multiple buildings by adhering with those specs. In addition to that, we know how hard it is to understand whether there are discrepancies from the spec and the actual data. We have built a error visualizer and warning visualizer that allows users to inspect visually what are the possible errors that data has brought in during the conversion. And this is a very powerful tool to help scale, bring rapidly awareness of where the errors are.
Okay, great. And then I think it'd also be great to understand how you can actually add more details to the map, because you were mentioning earlier you can add physical assets, additional things to the floor plan. So it'd be interesting to understand how you can, what details you can add to the map.
Absolutely. So let me switch for a second to the documentation. In addition to the drawing package requirement, through which you will learn that we can handle physical spaces, logical spaces, the openings to enable wayfindings, walls, vertical penetration, and other point of interest. In addition to this, which is fully embedded within Creator, you can also take advantage of the SDK to overlay and enrich your understanding with additional sources. And I would recommend checking out the samples and in particular the SDK spatial I/O module. This is a module that allows you to load a variety of different formats, including KML, which is widely used, into the same SDK experience so that you can fully leverage your securely hosted private data, the Azure Maps content, as well as third-party content that you may have.
And I love this site, the Azure Maps Web SDK samples site, the landing page, because I believe there's like over 200, maybe 213 code examples already ready to go. So you can see it in action right away. And then you can also get the code. This is across all of Azure Maps. So everything is nicely open source on GitHub for you. And it's really helps when you're trying to do a proof of concept and also go into production to be able to get all of these samples.
Absolutely. It's available for immediately test as well as the GitHub code directly. So as we walk through the experiences, as I mentioned, one very frequent input data source that is used to onboard new indoor maps is CAD drawings that are coming from engineering work. You see here a single floor plan that is one of the layers that we expect to find in the CAD, which is the unit, so the physical spaces. And the second layer of information you see in this particular drawing file is the room number or the room name. Mm-hmm. This is a very common set of layers that you will find in the majority, if not all, the CAD drawings files. And that is what we use to help bootstrap the generation of an indoor map. So everything you see here is automatically imported into Azure Maps through the conversion service. Not only, this room number are also used to augment the knowledge you can have about the spaces. So this is the manifest, is a metadata file which is imported as well during the conversion. Mm-hmm. It contains some basic information about the building, such as the business hours and so on. And then it enters into the reference to the CAD drawings. And even more importantly, it allows you to decorate that floor plan with each individual space with additional metadata. And here is just an exemplification. So very commonly in applications, there is a benefit to categorize the space. So in this case, we are categorizing office, conference spaces, restroom, and also add additional information like navigability or alternative name, whether it is a public space or not. And the way we combine these two different sources is through the unit name. So that label that you saw in the CAD drawings is also used here to basically join those two sources together during conversion. And this is a very powerful process that you can take advantage of.
Yeah, I can imagine, because if you have to sit there and take all of your data and put it in a totally different format that you don't already have, the time that would be required to get that done would just I can imagine take a very long time, especially if you have multiple buildings, multiple rooms. So this is definitely nice to have that conversion tool.
And we have seen this format being used, for example, to connect to other sources of information that are also further streamline it. Think about Microsoft Graph, which powers Exchange, Outlook for meeting rooms. You can think about using those Microsoft Graph API to actually gather systematically this information that would also be used within Maps. And this definitely further expedites the onboarding of new maps. So once you have gathered those drawings, this is what you will basically upload through an API. And I'm using Postman. It likely is going to be for you a script or an Azure function or an ARM template that you can use to actually deploy all these capabilities. And what we upload is actually the zip file, which contains the drawing DWG files, as well as the manifest data. So this is the first step that allows us to basically connect to a user data identifier. This user data identifier is then used by conversion. And this is where most of the magic happens. We take these two data sources, we can absorb that UDID, which points to the zip file, and then run the conversion. Before the conversion, there is a full process of validating the data. Very often, we also run additional logic to make automatic adjustments to help you rework on the data. And everything that happens is actually tracked. And as I mentioned earlier, it's going to be made available in the report of the conversion itself. So you see here, you get a operation ID, it's succeeded, and then you have a link to a additional resource which you can use to expect warnings or errors that occurred during the conversion. And let me show you how that looks like. It's basically a report that focuses on the data that has been either corrected or has actually generated an error, and it was omitted from the import itself. So every time you click on a particular warning, you have a reference to the data, and you can visually inspect and understand from the error and the error code what would be the appropriate action to take. And it may be none, because we run a lot of automated data correction for you. Now, once the conversion is done, this is for a single building. You can then use it to either create a new dataset, through which you will basically add reference to the conversion ID to index it and make it available, or append to an existing one. And this is the option that you would use if you are willing to create a single dataset that contains one or more buildings. That, again, it's providing a lot of different benefits in terms of data maintenance, in terms of rendering, because you will have a single layer. It's really up to your use case. Decide how many dataset versus how many building in a dataset you will want to create. The Tileset service I was referring earlier for rendering is basically generated a hosted vector tile, which is a super powerful, already in use in our Azure Maps data product to deliver on the client in a fast and scalable way maps. So you can basically fully embed and incorporate the same tileset within the SDK and other systems as you already do with other Azure Maps layer. And the process is driven by a data set. You basically pass data set ID, and you obtain at the end a data set reference that tileset reference, sorry, that you can use to then configure your application, like we will see in a second. Now, the last element of map creation is what I mentioned as runtime dynamic styling. So in this case, the dataset I'm using is having meeting rooms, spaces in general, as well as some desks, as well as some printers. So what I'm going to do here when I create the feature state is actually define what I'm going to listen at runtime that is relevant for my map. In this case, I defined occupied, which is a Boolean, which I'd like to use, for example, for desks. I defined printer status, which is another Boolean, obviously for representing the status of printer. And then I have an additional observation coming from IoT that is defining the temperature for a given room. And for each of them, as you can see here, not only define what parameter I'm going to receive, but also how I would like that to be styled. So if the temperature is below 66, this is the color. And you have a variety of options for styling that I invite you to look at the resources we'll link later at the end of this session to learn how much you can actually do to deliver all this. Now, this kind of concludes the pure mere set of activities you need to run to create the map. I'm going to switch to the SDK and the services that you can instead use to build solution. And I will start from the documentation. You have here through the Azure Maps doc a set of references specific for creator, but also here, for example, for rendering, you have you will see that rendering, single rendering experience has been extended to not only handle the hybrid, the imagery, the road, the traffic data we already provide, but also the your own maps. So by providing a given tileset ID, you can actually leverage that and consume it directly into your map application. For exploitation, Azure Maps, in addition to Creator, also delivers an additional set of experiences through the existing REST API. So if we look, for example, to render, here is where you have the get map tile, which should be already familiar with, which has the ability to get a tileset ID. Typically, you use this one to reference the base map, change style, get the imagery layer or road traffic. In addition to that, we added the ability to reference your own layers, your own tile sets, which allows you and the SDK to basically smoothly augment the data we already provide with the layers that you actually created and own. So this is an example of how you can configure the tile set and use the render. We'll see in a minute how this plays into the SDK. But before doing that, here is Postman, where I want to show you the most common ways that you will want to use the OGC feature API to actually learn more about the content that has been ingested into the dataset. So the dataset in this case is the main driver for the parameter, and you can learn about the different objects or object types we call feature classes that you can store and read through this interface. This includes the physical spaces, the opening, the point elements, which represent the point of interest. Everything that you can technically ingest is actually queryable through this open standard interface. A common example of use is the ability to gather what space and object categories have been actually used within the same data set. You see here room conference, restroom, everything that you are interested in so that you can do additional queries. Another very common one is the unit, so the physical space, the actual rooms. You can query just the feature collection so that you grab all the units. You could restrict the query, like in this case, to a given category of spaces, like room conferences. And you may even run a lookup to a specific room name, like room name 11. In this case, what you get is the feature that represent that particular room. And this is particularly handy because, as you will see later, the dynamic styling requires a reference to the feature ID so that you can actually reference what is the measurement about. Similarly, you can get a query using the category and the point of interest that allows you to gather the printers, in this case, like HQ poster printer or desk. Very similar experiences that allow you to browse and query the different content that you may have put into your system. Now, this is very common, and you will see in a minute why this is very helpful when you do dynamic styling. But let me switch to the SDK. Mm-hmm. The SDK is available both as a live link, like I'm making use here, or as an NPM package. In this case, I'm loading both the main Web SDK module as well as the indoor module. And this allows me to basically start making use of a specific indoor function. If you are familiar, every sample code template that we have includes the standard ways to authenticate. In this case, I'm using a subscription key. And in addition to the normal or the common things you would normally do in Azure Maps, we are adding a reference to those tileset and stateset that I've been creating out of my indoor map. And then I create the map object. The map object is standard, is part of the Web SDK module. I'm loading with a specific road layer because I'm interested in giving context to my building, but you can switch to others. And then I'm also enabling two things here that are specific of indoor. One is the widget to help control the floor picker, which is the level control. And the second part is to enable the indoor manager and enable dynamic styling. So with this configuration, my app is ready to listen to events that occur at runtime. Let me switch to the app. You see here, this is the app that is generated with very few lines of code, and the code I'm using is also available as part of our tutorial. So as I zoom in, all the spaces that I was looking before in a DWG file is being actually now being delivered through a vector tile, and I have my desk in this area, a printer here, which I can further use to visualize. And I can select the building, which allows me to enable the widget for floor picker so that I can actually browse different spaces. But what is important here is that all this information is driven by several properties that I've been loading into the dataset, including category type or object type that I'm willing to work with. And you see here a couple of rooms and the desk colored in green and red. And those are my very arbitrary style that I've been defining during the feature state creation. So those 3 rooms, as well as, for example, this 6 desk, are exemplifications of a dynamic styling behavior. Now, if I go back to my Postman, I will show you how you can actually update the map. Let's pick, for example, room 11. So we know the label, and I can use WFS to grab that feature ID and update the state. And I will do the same for a desk. So you see here, I'm going to, for example, make use of the unit. And here I want to update room name 11, which has unit 132 as the feature ID. And this is what I'm using here. So I have access to an API that allows me to update the state of that particular feature at runtime. This data typically comes from IoT. It could be a different system, but the most common use case is IoT Hub or even Azure Digital Twin that has fed to Azure Maps a augmented view, augmented understanding of the measurement. And what I pass here, in addition to the reference to what I want to update, is the information, the actual measurement. So I'm going to mimic here. I'm updating the state, and I'm going to update the temperature of this room to, for example, 78 degrees. Mm-hmm. And this is a way to basically express that room 11 has now received a new telemetry data from a device, which indicates that the current temperature is 78. I can do the same for any other object. I will pick one here. Of course, I need to update the timestamp to kind of indicate that it's a new measurement. And I can, of course, make this systematic and programmatic. This likely is going to be an Azure function that responds to event from IoT Hub or ADT, so that the event can be captured and monitored into the map. So if I switch back to the map, you will see now the room 11 has changed color, and so this desk, which was associated with this tile and the ID I used to update. So everything here is basically driven by feature state updates and enabling dynamic styling. So that's a very powerful way to create thematic map that really are driven by IoT that shows the current understanding of the space. And this is kind of completing an overview of the most common use cases and best practices to enable dynamic styling, to enable feature query and feature lookup.
And I love this walkthrough. I'm also curious on, so I see the icons for the bathrooms and the different rooms. Where are those icons being stored?
Yeah, so this is one of the benefits we provide. We provide a long list of categories, and for these categories, we also ship icons. Of course, you can change those, but the benefit of what we do is that once you import the data, you already have a QA'd, perfectly styled map that you can use. And of course, you can keep augmenting and add additional layers as you wish and need for your problems.
Okay, perfect. And I know we're talking a lot about the different data formats you can bring in. I'm wondering, since it sounds like it's a lot on the developer and the customer partner side, their data, how can they manage who has access to that data? And then what is this, just overall, what does the security look like? Because I can imagine a lot of partners, customers, developers, might not want to be sharing out this data, to third parties or anything like that, and also want to make sure that their data is being protected. Could you give a little bit more information there? I'm pretty curious on that area.
It is a very important topic, and Microsoft is very committed to keep it secure and compliant. So I'm showing you the view in the Azure subscription of an Azure Map account, where you have access to creator configuration. And here is where, for example, you select the geographic region in which you want your data to live. And in terms of security, the security is related to two main mechanisms that we already support at GA level in Azure Maps. One is a shared secret, And the second one is the ability to connect to a Azure Active Directory, so that you have automatic user identity management, and you can define your own roles to then kind of characterize what each user and personas has access to. And this data is fully owned and accessible only to the customer through their account. It's not shared otherwise.
Okay, perfect. And then looking at the roadmap, I know we're in public preview right now, but what are some extra features that might be coming along the road? I'm curious on what are some extra things we can look out for.
Yeah, this is a very exciting phase for us. I would say stay tuned. Our primary goal very soon would be to enable additional options for you to curate the data. So I already mentioned that we make use of Open Geospatial Consortium standards. Our plan is to make that experience available through different tools that exist already in the market, as well as include into that experience the editing. So if you were to add or change the room name, or have a second thought about what color or category that the purpose of that room is, you can do that at any point in time and propagate those changes throughout the system. And the second main activity we are currently conducting is the ability to implement wayfinding as well. So that's an area of the roadmap where we are looking at how we would help a customer reach a particular area of interest through this experience.
Okay, perfect. Well, thank you so much for giving that technical walkthrough, showing the different tools. I want to give an opportunity for you to share any last things on best practices. What are those top, maybe a top question that working with partners and customers that you have continued to heard and want to share feedback on or share insights?
Yeah, my additional insight is really familiarize, make use of the tutorial and the sample data we share to familiarize with the solution. There are many different options that fit a specific problem. We believe that our dynamic styling is a very powerful mechanism for any type of style your customer may want to see that is not available at static time. I want to see how many people are in the room. I want to see what's the temperature, what's the comfort zone, what's the feedback, or what's the income or the demography within the space, out of many different opportunities that IoT provide. So that's a very important one, as well as look at the potential of combining indoor capabilities with outdoor. We really see this as a very common transition. While at the beginning it could be a very indoor-centric experience, it's very frequently evolving into an indoor-outdoor, outdoor-indoor type of experience, and that's we feel very strong with our product portfolio.
All right. Well, thank you, Roberto. I think let's go ahead and share what type of resources that can help developers get started. So for a couple different resources, we recommend you checking out IoT Show. This is a great way to stay updated, get the latest on, what are some partner spotlights, new features, and also the deep dives. So we took a break while we were preparing for build, but we have deep dives every Monday for June and July. So we're pretty excited to have you join us for each one of those. And we also have the IoT Tech community. If you haven't signed up for the tech community, definitely recommend you check it out. You don't even have to sign up, but you can actually just view the forums. But it's a great way for you to see what the community is doing, ask questions, read blog posts, share your projects, talk about some challenges you might be facing with your own scenario, or share your best practices with other folks. We're on there there, and definitely want to hear your stories. And then tutorials that Roberto mentioned earlier and throughout this event. One is how to create your first indoor map. We also have tutorials on geofencing and IoT projects, and goes also through the experience of what Roberto just showed you on creating your own indoor map. Next, that page that Roberto showed with all of those samples, how we have over 200 samples with Azure Maps, that's on GitHub. There's that vanity link right there to get started. Definitely recommend checking that out. Honestly, it's one of my favorite pages that we have on GitHub because it's so many samples, really easy to get started with. And then if you're not familiar, we do have Microsoft Q&A. This is a new thing that we showcased at Build. What's great about it is if you have technical questions, if you have business questions, we are on there. So myself, fellow software engineers, they're on there to answer your questions. So if you have questions about Azure RTOS or indoor maps and what are some best practices there, or have some challenges you're running into, or request, definitely check that out. And of course, there's always ways to go on GitHub and submit issues and pull requests, and we're definitely on those channels and want to hear your feedback. And Roberto, is there any other channels you want to call out on providing feedback to the team?
No, those are the most common ones. Thank you.
Okay, perfect. Well, thank you so much, Roberto. Thank you so much for everyone who's joined, asked questions in the chat. That was great. And then also hope to see you out in the next deep dives. Thank you.